Hello everyone. In this video we're going to look at an interesting topic, and this is not very complicated. This is based on what you learned in the past, but this is called recommender systems, and this is like when you go to Netflix or Hulu or somewhere and you see they recommend some movies to you to watch, or you go to Facebook or YouTube and they give you some ads. How do they know which kind of ad or which kind of movie you might be more willing to see and put time into? Although sometimes you see they are not doing an amazing job, but I mean, like, what kind of system are they using, right? So, what kind of deep learning is that? That is called a recommender system. So, they always collect data from you, from your browse history, from what you watch, from the ratings that you give them, and so on. And here, to make life very simple, we assume that all they look at are the ratings that you give to the movies. Although it's way more than that, but let's say here, in this case, just to make the life simple, let's say they have 6 movies and they have 3 users. In reality, they have basically millions of users and thousands of movies. But here, for simplicity, 6 movies, 3 users. And let's say the first user with user ID 1, he watched movie M1, M2 with ID1, ID2, ID4, and ID6, and these are the ratings out of 5 that person gave. The second user, she watched movies 3, 4, and 6, and when we say 3, that means Titanic, 4 means City of Angels, 6 means, let's say, The Exorcist, and so on, and third person, he used M3, M1, M3, M4, and M5. And again, so they have a list. They know which ID of movie corresponds to what, and they have a list of which name corresponds to which user ID. Okay? So, based on this, they want to suggest you something. By the way, as I said, in reality, there is a lot more that they have to look at. It's not just the rating. And you might say, what kind of factor they might also include? Well, for instance, your browse history. Okay, they look at that. They look at your age. They look at your gender. They look at how much time you spend watching a movie or ad, right? Sometimes you see these ads that come to you, you just want to wait for the time on YouTube to say skip, and you skip it because you are not interested. But sometimes you let a 1 minute or 2 minute ad to just go on because maybe it has attracted your attention, or maybe you're doing something else. Okay, that's one of the things. But whether you watched the movie in one set or you did it in several breaks and so on, so there are lots of things. But again, here for simplicity, assume that the only thing they care about is rating to make life simple. And the other thing is they have different genres of movies, right? So, for instance, the first 2 movies could be sci-fi movies. The second 2 movies could be, for instance, romance movies. And the last 2 movies could be horror movies. Okay? So they have these different genres or different categories of movies. And now when they come and look, they say, oh, look, person 1, he watched 2 sci-fi movies and he gave good ratings to that, but low rating on romance and horror movies. Person 2, she loved more the romance movies but not a ton on horror movies. And person 3 seems like he liked more of romance movies but not too much on horror and not too much on sci-fi. Okay, so it's kind of, if it's as clear as this, then I know I need to go to another, for person 1, to another sci-fi movie, for person 2 to another romance movie, and person 3 also probably another romance movie, and suggest to them. But to do this better, they need to fit a function to the ratings based on the ID of the user, who is doing it, and based on what kind of movie they are seeing. So basically what you're doing is fitting a function, a multivariable function, where the function is the rating, the result of it, and the variables are what? Are the user and the movie. So these two you know, this rating is also you know. What you don't know is that function. And guess what? Neural networks, as you know, are one of the best things they do is approximating functions. So here we want to approximate this multivariable function f. Here are 2 variables, but in general we can add all of those other variables too. Okay? Now, what is one problem that we have? The first problem we have is the user ID and the movie, okay? In general, these are categorical things. So this user, unless you turn it into a number, this movie is a name and this user is a name, okay? So we have to turn them into numbers. So one thing we can do is to turn these names and name of people and movies into numbers, into a bunch of numbers. And if you remember, this is what we did in natural language processing. We used a layer to do that for us. And if you remember, it was an embedding layer, huh? So we can use an embedding layer, and we can turn that into an appropriate vector. Although if they are just names, right, you have to convert them into a number before passing them to a layer. You need to create positive integer numbers. But as I said here, instead of the name, I can use an ID. And instead of the movie name, I can use a movie ID. Okay, so these are already some integers, like this is 6, this is 10 or 100 and so on. So these are already numbers, but I have to first pass them to an embedding layer. So for each one, I have a vector in the d-dimensional space, where d is the dimension that we choose. Now, what's the problem? The problem is I have one branch on the right, I have one branch on the left. And now I have to bring these two parameters, these two vectors for movie ID and for user ID after embedding, and concatenate them. And then the concatenation of these two inputs is going to basically be used to approximate the output X, which is the rating. Okay? And in order to do approximation, all we need is a regression, simple artificial neural networks, which we have done in the past, and then we do a prediction of the rating, okay? But the only thing we have here, and we have to pay attention, is here is not a simple sequential network. If you remember in the past, the sequential networks, we had some data, it goes to some layer, it goes to another layer, it goes to another layer, all the way to the end, right? So it's just one branch. Here you have two branches that in the middle, they are merging, they are concatenated. So this is not a typical sequential network, okay? How do we form this? I'll show you in TensorFlow, but pay attention that you cannot use the under from Keras layer sequential. This is not a typical sequential thing, it's not. I mean, this portion of it is, but the top portion of it is not. So fine, let's say you formed a network and you did some predictions, you found a function f that now if you give it a new user and a new movie, it can give you a new rating. Now, why would you need that? The reason is many of the cells are blank. Not every user watched every movie, okay? Because typically these Netflix, Facebook, YouTube, and so on, they have thousands and thousands or sometimes millions of movies or ads. Of course you cannot, and you should have, you could have not seen all of them. So now they go to these blank cells and they try to fill it. They say, hey, look at person one. Whatever movie index, movie ID that this person did not watch, go ahead and predict based on this function f what rating that person would give to it. So it says, okay, probably this one is going to be a 1 out of 5, maybe this one is 0 out of 5, okay? And if there is, let's say, another sci-fi movie here, then that one might get, let's say, another 5 by 5. So now what do? They come and look at all these new predictions. And they suggest you what? The one that got the highest predicted rating. They suggest you those because they are more likely to be seen by you. Okay, so here let me show you the TensorFlow code that I have written here. So you need the NumPy, you need TensorFlow, you need Matplotlib, you need Panda, and you need some layers from TensorFlow Keras layers, which are dense, input, embedding, flatten, concatenate. Here we're going to use the stochastic gradient descent for optimizers. We use the model for creating the model. We also use shuffle to make the data in the CSV file shuffled and make it really random. So the CSV file we have here has 3 columns. It's called rating.csv, which I'm gonna give you a download link for it. I only use the first 3 columns in it. The first column is the ID of the user, the second column is the ID of the movie, and the third column is the rating out of 5, okay? So you can see that by looking at the head of this DF. Now, the data in the first column and the second column, these IDs, might not be exactly perfectly numbers from 1 to what, from 1 to whatever the number of the ratings are, which in this case is about 2.2 million, a little bit more than 2 million ratings. So this is a huge SV file. And to assure that the numbers in these 2 columns are proper, and there is no missing number or anything, because if there is missing number, you're going to get some errors. So here you see that these numbers are generated again. So we convert the data under user ID of this DF. We use the PD under Panda categorical to convert them into categorical variables, and then we convert those categoricals dot codes back to numbers. And these numbers, which now we call a new column, new user ID, are hopefully exactly from what? From 1 anyway to 2 million, with no missing number and basically no mistake. And we repeat that for movie ID. So now we have 2 proper values, 2 columns. And now we use those values of these 2 columns and assign them to user ID vector, to movie ID vector. And then the rating column, the value of that we assign to what? To the rating vector. So now these 3 vectors are ready to what? Are ready to be used for the network. Now, how many users are in this CSV file? You see that 138,000 people. How many movies are available? You see more than 26,000 movies are rated here. So how do we create the network? Here we need 2 input layers, because we have one for the user, one for the movie. And since they are taking over scalars, we only use a shape of 1 for them, because a user ID or a movie ID is just a simple scalar. Then we need our embedding layers for the user ID and movie ID. So the dimension of them is number of users and number of movies by D. D is the output dimension of the embedding layers, which you can choose. It's a hyperparameter. Here I go with 10. Feel free to change it if you want. And then before we pass them to the concatenation, we need to flatten these results, then pass them to concatenation. You might say, why is that? Because the outputs of these embedding layers, the dimension of them is number of samples times 1 times D. While when you want to concatenate them, you cannot concatenate them like that. You have to get rid of this extra dimension of 1. That's how this concatenate. Expect that these 2 numbers that you pass to it, the dimensions are like basically they are a 2-dimensional matrix, not 3-dimensional. So you need to get rid of this extra dimension of 1, and that's this what this flatten layer does for you. So you get rid of them, and then what? Now you can pass these 2-dimensional results to concatenate. So if you do that, you call the output of concatenate X, you pass that X now finally to what? To your regressive or regression network, which we had in the past. What you need is first a dense layer before the final layer, and the activation function. You can use different types of function. We found that ReLUs are good. Here is the number of neurons in that dense layer, and here I use 1024 or 2 to the 10. You might say, isn't that a big number? Yes, but remember that you have tons of information, tons of users, tons of movies, tons of ratings, and so you better not go with a very small number here. Otherwise, you cannot learn this multivariable function. The last layer will just spit out a single rating, so it should be a dense layer with a single neuron. And remember, since it's regression, the output layer should not have any activation function, or it should have the default, which is what? The linear activation function. So make sure this last one don't pass to it a softmax or sigmoid or something. Now, when I want to merge these two and combine these two parallel branches together, this is how I do it. I say model, and then instead of giving it one input like we did in the past, I, and one output X, here we say inputs. And then we combine IU and IM, the two initial layers, with a bracket. These are the two inputs, but the outputs here is a single X. So that means these two parallel branches are merged. For optimizer, we use SGD with a learning rate of 0.08 and momentum 0.9. Again, these numbers are under our controls. Feel free to change them. It's a regression, so we use mean square error for loss. And before we apply the fit, we need to break down the total data we have into training and validation. So first thing, I shuffle all the data. Okay, so if there was any order in them, we get rid of the order. And then I use 80% of the total number of ratings, 80% of 2 million, so it's about 1.6 million data for the training, and the remaining 400,000 data for what? For the test. Okay, so from 0 to ntrain for training, and from ntrain to the end is what? The test data. One last thing you want to do is to normalize the data, both the train and the test ratings. And here, since the numbers are just out of 5, we have to, well, subtract and then divide by the standard deviation. But the standard deviation of these ratings are not really much bigger than 1. So all I did here was to subtract the rating of the training data from them, and I did not divide by standard deviation. If you want, you can do that. So instead of numbers between 0 to 5, now I have a bunch of negative and positive numbers, which are around like between negative 2 or 3 to positive 2 or 3. Now I combine the train user IDs and the train movie IDs into the input. The output is the train ratings. So these are my training data and training targets. 25 epochs. Feel free to change that. I'll show you 25 in this case is good. You can go with the batch size here. I use 1025. You don't want to go one by one here, okay? You have 2 million data points. You don't want to do 2 million updates. You better use a batch size. And here we use 10,000. So we have about 1,000. So we have about 1,000 batches. For validation data, you see I combined all of the test user IDs, the test movie IDs, and the test rating in a single parentheses, where the inputs, the two inputs, are combined with a bracket. So these are the test inputs, and this is the test target. Okay, and one last item I have here is this guy called verbose. So verbose means when you are doing the training or later prediction, what kind of information do you want to show here? Remember in the past when I did this, we had a bunch of these progress bars, huh? So if you don't want those progress bars to be shown and you want your training to be done faster, you can say, hey, don't show me those training bars. So you say verbose equal 2. Right? Sometimes you only want a portion of this data to be shown, so you might use what? Verbose equal 1. And sometimes you don't want any of this loss, val, loss, epoch, anything to be shown, right? You just want the work to be done in the background with no updates, and then at the end you get your result. Then you can say what? I'll show you down here. You say verbose equals 0. That means, hey, don't show me anything. Just show me this final print if there is something. Okay, so you can basically control how much of information and update to be shown. And this is a new thing, so I explained that. Now here I plot the loss function for you. You see the training data is going down, and if I increase the epoch, it can probably go further down. But on the test data is kind of plateauing, and you want to make sure that you don't go further, okay? Because if you do, you are fitting just the random variations in the data which are not explained by those two user ID and movie ID. That means you're overfitting. So what you want to do in this case is, if you want, you can go back and change your learning rates. You can change your momentum, right? And you can try it again, maybe this time with more epochs if you use a smaller learning rates and more momentum. And you might be able to achieve a better result. But remember, at the end of the day, a portion of these ratings might not really be explained by these two variables, because as I told you, there are a bunch of other things you might need to consider, a bunch of more variables: browsing history, gender, the times spent on these movies, and so many other things. So in reality, this function is not just, it doesn't have just two variables, it has more variables. So if we use only two variables, we can only partially explain the ratings and not all of it. And so you should not really expect this generalization and the error on the test data or loss function to go down to very small numbers like 0. Okay? You might change your optimization technique. You might get it a little bit better, but it doesn't mean necessarily that you can get it very close to 0. Here is the plot of the network. You can use the Keras Utilities plot model if you want, and this is what I told you. And finally, here we do some predictions for one user, specific user 100 with ID 100, and we only go for the first 1,000 movies and see if I want, between these first 1,000 movies, if this user, I have to suggest one movie to watch, which one do I suggest to this person? So here I create these vector movie ratings, which are the ratings predicted by the network for the first 1,000 movies. And I start them at 0. Then I use a for loop for each one of those movie indices. I use that movie index, and I use what? I use user 100. I pass them as the inputs to the model predict. I ask it to not throw out any updates. So this will give me the predicted rating. And remember, we subtracted the average rating from everything. So now we have to get it back. We have to add it back. This is undoing that standardization here. Okay, so we add that rating mu back to it, store it as the nth value or the ith value of this movie rating. And here by the 0, 0, we convert it to a scalar, so we can store it here. Then finally, we look at which one is the maximum with argmax, and then we say, hey, give me that argmax. And here you see that if person 100 has to watch a movie, the ID of that movie is 294. That's what the network thinks this person would rate the highest. And so this is what the network is going to go look in the list, see which one is M294, and suggest that to you. Okay, so hopefully this video was useful to you. You got some very basic idea of how these recommender systems are working, and I'll see you in the next video. Thank you.